This talk, as you can tell, is all about CI/CD in GitHub Actions. And automate some stuff. I like automating stuff, I think it's good. This talk is so unprepared that my notes say intro here. So I literally have no idea what I've got to say at this point. But this is an awesome talk, we're going to have good fun. Mostly I want to think about how we test and release software. I think this is an interesting question in and of itself, because it turns out that we're not very good at it. As a blanket general rule, I'm sure that there's an exception in the room where your release process and your test process is absolutely wonderful every single time. The rest of us are still learning this. So workflows to get a code change into acceptance. How do you accept a code change? Right. Traditionally, we would say, well, I say traditionally, in the Git world, we would say merge into main. But basically, we talk about accepting code. What justifies this new bit of code to go into our main branch? What we're going to do to make sure it's good? We're going to check the source code out. We're going to install the dependencies. How compile it if it's a Go library, for instance, or Kotlin or something like that, or JavaScript nowadays. Go create a container otherwise, maybe, something like that. Then we're going to run the code style checks. Is the code an acceptable shape? We're going to run some quality checks, run the tests. And then we might get some errors, we might get some logs, we might get some test output. We're going to have to send that back to the developer to fix it because it didn't work first time. Again, I appreciate that you might work for that organization where every single PR perfectly works every single time. The rest of us, test output happens, we might need to send it off to the developer, and we need to tell the developer whether it worked or it didn't work. That's fundamentally the set of stuff you do. Probably. What about releasing to the world? Release some software. You've got to check out that source code again. You've got to compile it or create a container. We're going to upload that container to the registry or put the executable that we've created into the release. Got to deploy it to production or into the orchestration platform. Publish it and tell the world. I've put tell Slack because normally we just see a notification on Slack, but a whole load of stuff happens after that related to marketing that literally we don't care about. It's fairly rare to get a list of things right in order the same time every time. That's a fairly rare thing to do because humans are really, really bad at repetitive tasks. That's why we invented computers. They are really good at repetitive tasks. Give them the wrong input and they'll give you the wrong output every single time. So tests ensure that our software will work. CI will ensure that we run them, continuous integration. CD, continuous delivery, will ensure that we can release it reliably. So this is all about automating processes to get things done. In the development world, the repository is everything. That's where our source code lives. That's probably where we've got a whole load of processes around code review as well. So GitHub Actions will run scripts on that repository when an event happens. Keyword there is event. From now on, there's an awful lot of YAML. GitHub Actions uses YAML. I'm sorry. It's not my favourite language. I think there are better choices, but it is the one that we all use in this day and age. So be prepared for lots of YAML. Because the GitHub Actions automation flow is defined by a workflow file. And the workflow file is a YAML file. And it looks something like this. This is a nice, dead, simple one. Has to have a name, CI. Has to have the event triggers. This one will be on a push or a pull request. That's when it will run. These are the list of events that you can run. There are a lot of them. GitHub gives you lots and lots of places to hook into the system. All the green ones are repository events, something that happens within the GitHub world itself. One of these green ones will actually trigger, like a discussion or a status change or a merge group change. Loads of different things happen. The orange one is a webhook. So you can trigger a GitHub workflow from the outside world. Anything you can imagine. If you can do an API request, or push, you can do a GitHub action run. The magenta one is cron jobs. You can do them on a schedule. Run them once a day, once an hour, whatever. What's the blue one? I didn't write down what the blue one was, so I literally have no idea. The blue one also exists, and I would better write that down for my next talk. And lastly, you can run them manually. Then we get to the list of jobs. So the jobs themselves, they have a name again, and they've got a runs on, which is the container they're going to run on. So this one is Ubuntu latest, but you might also want to run on Windows, you might want to run on Mac. It costs more to run on Mac or Windows. We all run on Linux for a reason. And then you've got your steps. This is the things that are going to happen. Not a lot of complicated stuff there. Each one's got a name and a run. So the run is bash by default. So echo hello world, and then echo all done, or say goodbye, something like that. Plug it in, do a pull request or a push, and we will end up with a response. And it's all perfectly fine. It's all worked. We get these lovely checkboxes that say a tick. If it doesn't work, you get a red cross, and you get a notification and an email, and it tells the world that you messed up. Quite easy. I had to cheat a little bit and had an exit 1 to force an error, because it turns out that it's really hard to make echo fail. But practically, what happens is if one of your processes doesn't return a status code of 0, it is considered an error. Any other status code is an error. And GitHub tells you. That's it. That's basically all the automation is. So the rest of this talk is mostly a sort of cookbook, the sort of things that I do, things I've done for my clients, that we've done in production, various clients for projects to make them work reliably in our world. So I'm just going to show you what we do basically from now on. Common thing we do with PHP code bases is we check them out. GitHub Actions doesn't by default check out your source code. You have to do it yourself. That's what the checkout one does, that one. So you need to check out your source code. By default, it only checks out a very shallow copy, by the way, because it's quicker. And then normally there's some sort of env file involved, environment variables of some form or another. My general rule of thumb for the stuff that I do is I store it in a .env.ci file, and then I just copy it to .env. All my developers have got a .env.dist file that they've copied to .env as well. So it's the same process we use in development as we use in our CI system. Need PHP. Contrary to popular belief, PHP is not installed on every computer in the world. You have to install it yourself. There is a wonderful project from Shiva which will check out PHP for you. It's a lovely action workflow. And one thing that this shows you is that you don't have to write all of it yourself. There is a marketplace where you can grab actions that other people have written. So you'll notice there's no run statement in this one, because there's a uses. The uses tells us we're going to use a third-party action, and it has the run commands. So it will do the work for us, and we just have to provide some parameters. And I'm telling it I want the pcov extension for doing coverage in PHP unit, and I want to use Composer, and I want to have CS2PR installed as well, and it will do that for me. It's your PHP project. It's a web project. You're going to have to run Composer. You're going to have to run npm. So create a couple of steps, stick them in. An interesting thing here is your Composer install --no ANSI will result in output you can read in the console without silly bits related to turning the colors green and red, which is quite nice. And no interaction will mean that we won't end up with a prompt, which is also helpful because there's no keyboard attached. Check the code style. We all run PHPCS, and PHPCS has got report check style output, and CS2PR will take that check style output and put it against your pull request and annotate the pull request where the errors are, which is super handy. Static analysis chests, We use PHPSW on this project. SAR is equally valid. And your unit tests, of course. You're going to run some of those as well. Again, I have a custom PHP unit test configuration file that I run, so I pass that in as well. Standard stuff. You're probably already doing this already. What about some other checks? Check the licenses of your dependencies. This might not be a problem you have, but I've had at least 3 clients now that have had opinions about the license of the code that runs on their computers. Turns out that lawyers care about these things. Hence, sometimes we have to care about them. Specifically, things like GPL v2 can be a little bit complicated with some particular clients. Other clients, maybe they don't care, but some clients do. We had this problem. We needed to ensure that we never installed a dependency that had an invalid license. So we wrote a script and we put it into our CI system. The CI will fail if someone tries to have a dependency that doesn't work. Super helpful if you have that problem. Can you cache the roots? We had another problem on another project where PHP artisan root cache was failing. And we only found it when it went to production. Can't remember why. It might have been we'd named 2 roots to save or something. I literally can't remember why. It happened once. We wrote a test, stuck it in our CI, and never thought about it again because it never ever got past CI. Tailwind build. This particular project took the Tailwind output and committed it into the source repository, so all the CS files or whatever it generates. I don't know Tailwind very well. So we wrote a check for the people that were running Tailwind in dev mode on their computer so they could see the change, but weren't actually building it into the CSS files that were then sent to production. So we put a simple check in. And all we do here is run Tailwind build locally on the CI system. If and only if those files are already up to date, there will be no change to the Git repository. There will be no modified files. If there is a change, the Tailwind build has done some work, there will be a change to the committed Git files. There will be a modified file. So git status -- porcelain will return an output which is either empty or a modified name. So we can test for it and hence exit out of our CI if you have failed to commit your Tailwind build. It only happened once because then we wrote a test for it. I don't know about you, but I'm a big fan of Docker. What I like about Docker is that once you've got it running on one computer, it runs on everyone else's computers, and we start having reproducibility. We don't have to worry about which particular install of PHP each developer has got on their machines and compare that to what's on production or what's on staging. It's all the same PHP, it's all the same source code, it's all the same set of extensions installed. I like Docker a lot. So we use Docker, I don't know about you lot, but we use Docker in our dev environments now, a lot of us. Why not use them in our CI too? So we're doing the same thing our devs are doing, but we're now doing it in the GitHub runner. Docker compose pull, we'll pull it out. We can cache our Docker layers, so we don't have to keep rebuilding them every single time when they don't change. Absolutely wonderful third-party action. Highly appreciate that one. And then, of course, we run Docker compose up to actually run them. Wonderful. We now have Docker running within our CI environment, which means that we've got MySQL running inside our CI environment, or we've got Redis running, or whatever else is in our Docker compose can now be running in our CI. However, MySQL is a little bit slower to start up than your average container. Don't know if you've noticed this. Sometimes it can be a little bit slower. So there's a lovely little script called wait for it, which is fantastically named. As you can imagine what it does, it waits till a port is available. So we wait for 3306, and now we know MySQL is ready to run. And then we can run our migrations. So now we're in a node database state, and then we can run our integration or functional tests or whatever type of tests we need to run against the database. Fantastic. I don't show it here, but you know what else you can do? You can run your playwright tests because you've now got a fully functional system inside your CI container, which is quite cool. Or your Selenium tests or whatever tests you use for HTTP. that test output. One of the projects I work with is called RST to PDF, which is what I use to create my slides. But what this does is I write my slides in a markup language like Markdown called RST. I convert them to a PDF file, and then I present my PDF file. RST to PDF's test suite generates test PDF files and compares them against a master PDF. So if you get a failure of a test, you want to know what was generated because it was clearly wrong. So we need to get that PDF out of GitHub Actions down to our computer so we can fix the problem. Upload assets solves that problem for us. Inside GitHub Actions, there is a reserved amount of storage space that you get as part of GitHub Actions where you can put stuff and then you can get it again. So the upload artifact third-party action will upload any files you tell it to. So in this particular case, we're going to give it a name of, there we go. We're going to do a conditional. This will only run if we fail. There's no point in uploading successes because I don't care about the successful ones. Only if it fails. Conditionals are fantastic on this sort of stuff. And then I'm going to give it a name, failed tests, give it the path to where all the assets are that I need to upload, and then, most importantly, retention days. GitHub is a very nice company. They're part of Microsoft. As a result, they are not infinitely generous. So you only get a little bit of space. Don't fill it with stuff you don't care about. After 8 days, if you've not checked this set of errors, you're never going to check them. So stick a retention day on there and it will auto-delete them so you can put new errors into your space. Fantastic feature. Lots of other things you can do with this. If you're running Playwright, for instance, to do your web testing, Playwright will generate you a screenshot of a failed test. You can do the same thing with your Playwright failed screenshots. Upload them and then you can diagnose it. Everything you run in CI, you should run locally. There shouldn't be a surprise that it failed in CI because the dev didn't test it. Well, obviously the dev didn't test it. The dev should have had the ability to test it, more importantly. This is another reason why I like running all my stuff inside Composer, Docker Compose. Because the side effect of that is exactly the same stuff that runs on the dev's computer. So now we can write a script. I use makefiles personally. I call it check, the target called check. So you can type make check and it will run the exact same set of tests and queries and checks as it will do in CI. So there'll be no surprises. Try not to surprise people. People don't like being surprised. So that's all our shipping to main bit done. What about the other half? We now need to do a release. There are many different ways to do a release, as there are software packages in the world, at least, if not more. Everyone does it differently. So we'll look at a few different ways of doing it. Firstly, what I'm going to do here is create a tag on my repository and create a release inside GitHub. The way this project works is we have milestones. So I don't know if you've used GitHub milestones, but GitHub milestones can have issues against them. You close the issues, they're all part of the same milestone. So then I can close my milestone, which is an event. So I can close it in the GitHub UI. The event triggers, and then I can check out my code. And now I'm going to create a tag on that code. So I'm going to automatically tag my code base on the new version release. You have to do fetch depth of 0 because you need a full checkout of the code and not a shallow checkout of the code. And until I had to deal with this, I had not realized how important a shallow checkout is compared to a full checkout in terms of Git. A shallow checkout you cannot tag. You need the full checkout. So do a full checkout. And you can see the age of this because I'm using the master branch still. That's how long ago I wrote this action. And then you can create a tag. We use a third-party action again, action create tag, and you pass it variables. The variables we pass in is the name and the milestone, because I name my milestones after the version number I want the release to be. So my milestone is 1.8, my next milestone is 1.8.1, my next milestone is 1.9. So I can use that as my tag name. So now I've got a tag on my repository. How cool is that? It's just got a tag for me. And that GitHub releases page, it can automatically do that for me too. That's quite handy. There is a super third-party action from GitHub themselves called GitHub Script. GitHub Script allows you to write arbitrary JavaScript within your workflow, within your step. And they include the GitHub SDK pre-installed. So anything you can do with the GitHub SDK, you can do within your CI action. And guess what? There's a create release option. So I can hit the create release endpoint, pass in generate release notes to true, because let's face it, none of us like writing release notes. Pass in a name, pass in a tag name. I know what they are. Automatically create my release page for me. Going to have to create a new milestone now for all the new work that's going to happen. So I can get GitHub to do that for me too, or get the action to do that for me too. So I've just closed this milestone. I've created my release. I've created a release, tabbed my source code. I've created a release on GitHub. I now create a new milestone within GitHub ready for all the new work. Just simple automation. There's again, I don't know if you know Rick C. Haxibus. He's a guy around the PHP community. He's quite a clever guy. Use his actions, they're wonderful. GitHub Action next send ver is magic because it can handle all the docs. So if you've got 1.8.1, it knows that the next version is 1.8.2 or 1.8.9 goes to 1.8.10. It knows that for you, which is quite handy. And then again, we just create a new milestone, pass in the title, and we're done. One thing that's different about this third-party action is that it's not by GitHub. And because it's not by GitHub, it's not trusted to work against your GitHub project without permission. Which seems like a really good idea, I think. So we need to pass in our GitHub token. Where do we get our GitHub token? We get it from the secrets. This is all running source code on your computer, well, on their computer, but it's all our code being run here. We don't put passwords in CI. We don't put passwords in source code. We don't put passwords anywhere where they are not secure. Do we? They definitely don't go on post-it notes, do they? In the GitHub Actions world, there is a section in settings called secrets. We put them in there. In bigger organizations, only certain people have access to enter the secrets. And because it is a secure place, you can't get the secret out again. It won't tell you what the secret you put in was. But it's now available to every action if you manually pass it in. A GitHub Action step does not have the right to read the secrets unless you explicitly give them the secret. So here we're giving it the GitHub token secret directly into this step, so this step can go and operate on our GitHub project for us. Okay. The nice thing about the GitHub token one is that GitHub produce it for us. And what's neat about it is it's a one-time token that only works for this run of the pipeline. So if you have a slightly dodgy third-party action, which this one is not, by the way, this is a good one. But if you had a third-party dodgy one, that GitHub token is actually no use to them because it only works once within the context of this particular pipeline. So that's clever. I've already told those bits. Another common thing we do, or I do at least, or clients of I have do, is actually create binaries, real actual CLI tools. What I'm going to show you is an open source project called Rodeo that I wrote, which is a Go application. I don't know if you've used Go, but Go is a really nice language for creating CLI tools. If you need to create a CLI tool, use Go. It's a Rob top tip. Such a nice language for this. One of the absolutely cool things about it is that you can compile for different architectures from other architectures. It's a really, really useful feature when you're using GitHub Actions. So in this case, once that release has been published from the previous workflow, this workflow could kick in. So I can separate out my workflows just by tagging off different events. So here we've got the published workflow, the published event. I now want to do some binary compilations. Obviously there's the whole checkout stuff, but you've seen that now, it's boring. Got to set up Go because it turns out that Go is not installed on every computer either. And then we can just build the Rodeo executables. And as I say, they build for different platforms. So although I'm running on Ubuntu Linux here, my little script called build.exe will generate the Mac binary, it will generate the Windows binary, it will generate the Raspberry Pi binary automatically for me. That's a really cool feature. So now I've built my binaries, they're all in a directory, then I can upload them. This should look fairly familiar. We've got a uses thing where we've got this upload release action. You can guess what it does by what it says. And again, we just pass it some variables. Which token do we need? Again, we need that secret. Which tag? Where are we going to put it? We want to put it against the release we've just done. Which files do we want to upload? And this particular action, you need to say file glob, otherwise it won't recognize the asterisk as a wildcard. And now I've got all my binaries attached to my release that was automatically created by when I closed a milestone on my project. So I closed a milestone, suddenly I've got binaries released to the public. I haven't touched a thing. It's just done it for me. And it did it last time as well. And the time before that. And it didn't get it wrong. Amazing. Of course, you probably don't publish binaries, do you? But you might upload your containers to a container registry. You might put them up to Docker Hub, for instance, or you might put them to AWS's Elastic Container Registry, which is what one of my clients did. And it looks exactly the same. You do the steps, we build the Docker containers, and then we use another action, GHECR push. Now you need your AWS access key and your AWS secret. You get them out of AWS, you put them in the secrets within GitHub. Well, actually, you get your DevOps people to do that because people like us don't touch the secrets on AWS, do we? Which region do you want them to go up to? What's the local name? What's the image name up on the system? And again, you'll go do your tagging because this is Docker. So we've got image name colon version number, image name colon latest, because we obviously want the latest up on our container registry as well. And we're done. We've just uploaded a whole load of stuff to the container. And I forgot that bit. I haven't shown it here, but the next step of that particular workflow is it then restarts the that's ECR, so it must have restarted ECS. Does everyone else have problems with AWS names? Yeah, so Elastic Container Services is the orchestration system that runs the containers. I've just uploaded my new images to the registry. I then trigger actually puts them into staging automatically for me. But it literally looks identical, but it's a different third-party action. Other stuff you can do, or things you need to be aware of. I've said this before, but secrets live in GitHub, not in Git, and not on Post-it notes. They live somewhere secure, and GitHub has a place to put them for your actions. Put them there. Conditionals are wonderful. That if failure. You can do things like don't run this if we don't have the PHP change. If there's no PHP files changed, why are you running the PHP unit tests? Doesn't seem particularly useful in the grand scheme of things. Conditionals, they're wonderful. They save time, is a big one. They save resources, but nobody cares about that because that's the finance people's problem. But the time matters because the quicker that a workflow runs, the more likely you are to actually use them. You don't have to use bash. I think bash is wonderful for doing this sort of stuff, but you can use Python by using the shell:python flag to your workflow step, or you can use PowerShell, should you wish to. GitHub CLI. If you're not using the GitHub CLI locally, start using it. GH, it's a wonderful tool for working with GitHub from your computer if you're a command line person. It's installed by default in the Ubuntu latest container. So you can do anything related to GitHub by the GH command line as well, which, if you're used to it, is really quite cool. If you're building a library, you probably should test on more than one version of PHP. So I built the Slim Framework library, or the Slim Framework. I suppose it's more than just a library, it's a framework. So we take the Slim Framework, we test it on PHP 7.4, 8.0, 8.1, 8.2, and 8.3. And matrices is a way within GitHub to tell it to rerun the same workflow for multiple times. I haven't bothered telling you anything about it because A, we're short of time, and B, if you're not maintaining a library, you know which version of PHP your target is, so you probably don't care. You're always hitting, my client is always hitting 8.2.4. That's the version it's currently in production. That's the version we've got in our containers. That's the version we develop against. We don't need to care about its 8.2 compatibility or 8.1 or whatever. And lastly, you've seen a lot of third-party actions. There are hundreds of them. That's where they are in the GitHub marketplace. Go and look for them and use them. They are very, very, very good. So that's it. The CI and CD are just automated scripting. That's literally all it is. We are just automating stuff we can do on our own computer so that it happens the same way every time. If you come across an issue during development, during deployment to production, during the review process, write another step into your workflow so it doesn't happen again. You will thank yourself so many times when it catches something that you had forgotten was a problem, but it happened 3 months ago. It's done in CI, it should be doable locally. Try to make it so that your devs can ensure their pipeline passes before they actually commit. That just makes everyone's life easier. I'll leave with this. David Farley and Jez Humble wrote a book called Continuous Delivery, which is actually quite a good book, but actually quite a lot of text in it as well. A deployment pipeline is an automated manifestation of your process for getting software from version control into the hands of your users. That's all it is. Unfortunately, that's all it is. The key phrase there is process. Your process. You have to have a process for reviewing your code, testing your code. You have to have a process for deploying your code. If you do not have a process, then this is not going to help you, and there will be a fire drill every time you do a release. Thank you. Okay, anyone got any questions?
We showed at the start that in the YAML file, it's reconciling the jobs and steps.
Yep.
How would you determine what the level of various steps are?
How do you determine the level for whether to use a step or I think they call them jobs, don't they? A job or a step. I have no idea. I only ever have one job in my workflow. I will create a separate workflow file for the next one. I find it easier to think like that. Other people presumably do other things. So I imagine if you do them separately, they will do a separate checkout into the GitHub UI, which might make it easier to work out what's happening when. And I would imagine, but I've never used it, I bet you can refer to a previous job in the subsequent job. So if you could do one job that does a build of the container and then have subsequent ones that use that container for different things. I try not to be complicated because I get confused. Can you? Oh, look at that. Me thinking on the... There you go. You can have dependent clause. Dave is the man who knows this stuff. So if you've got any questions about that, ask Dave. Cool, yep.
Step that order with respect to that.
Does the order matter? The order completely and utterly matters, yes. It starts at the top and works its way to the bottom. I'm really, really relieved it does it that way, because it would be a nightmare otherwise. And what happens is when one of those steps fails, the rest of them are not run. It will short circuit at that point. It will exit early. That can be super helpful, except for when you don't want that to happen. So if you have a step where it might exit with a failure, but you don't care about that failure, then you must make sure that you return a true from that particular step. So what you'll see is you'll see someone writes command blah 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 pipe true, which is the bash or symbol. So what bash will do is it will return the status code from the first one, unless it failed, in which case it will return true anyway. So you get around the problem that way. So there's a way around it, but in general, a step fails, you probably want to care about that step, and you probably don't care about running anything else because we've broken at this point anyway. If we failed our unit tests, it doesn't really matter that whether our integration tests work or not, practically. We're not going to release the software, so we may as well stop. Don't bother wasting any more time. Go and fix the unit tests. That make sense? Is that a good answer? That was a good answer. I've decided.
You've got that sense of what some of the boundaries are. It looks like you do almost everything with GitHub Actions all the way through to deployment.
And there is absolutely no boundary.
You get
All the way.
Yeah.
And the more you automate, the more chances you have of it being successful next time.
Is
So
there a point where maybe better tools can take it from deployment onwards? Is it, or will it get quite hard to maintain put too many actions in?
I don't. So maintenance is an issue, like, because it's YAML. Not only is it YAML, it's still code. Essentially, you're writing a code here. It's YAML, but it's a configuration file. It's like writing code at the end of the day. So you have a maintenance thing going on here. My preferred solution is separate workflows for separate tasks. So you saw that I had one workflow that did the tag to release on a close of the milestone, and a separate workflow that then generated the binaries or generated the containers. I would then have another workflow that actually started or deployed those containers. So I would separate out for maintenance purposes. What you can do in a GitHub Actions environment, the sky really is the limit. We've only talked about PHP deployment and testing, but if you think about it, you've got things like the ability to automatically close a issue if it starts getting too old. So if nobody replies to an issue for 3 months, you could close that issue automatically, for instance. You could have it that if a maintainer adds a label to an issue, that something happens related to that issue. Maybe it gets sent to a Slack channel. This issue is important, has not been looked at. You can literally do anything you can imagine if you can write code to do that thing, and it operates on your repository. I've had some that do things with Jira as a result of something happening inside the GitHub side of things. Easy to do. The knack is noticing you're doing it more than once, and I could automate that.
If you're writing your own GitHub Actions, how do you make sure you dry that up so you can read across your repository?
Carefully. Right, the way you do it is through all those variables. So you notice a lot of the third-party actions have got a with clause followed by a whole set of properties. That is because that uses third-party action is a generic action.
Okay.
You can loosely think about it as a function or a method.
Yeah.
So it needs to take parameters, and that's the with section. That's really common in the open source world. So I imagine it is fairly common in the rather bigger development shops as well. But something like Laminar automatic releases, for instance, is a mega set of workflow actions that does all sorts of things when you close a milestone. And the way the Laminar people have written it is it's deployed to all of their repositories. So they've got 20, 30 components. The same set of actions are run on all of them, and those are maintained in a separate repository.
Yeah, so that's where I was going.
So it goes into a repository.
Actions, you put them in a
You have to put them in a repository. Yeah, well, you have to have them in a GitHub repository because that uses statement takes a public GitHub repo.
Okay. Yeah, yeah.
So you have to do that because otherwise it won't pick it up. And if you notice those third-party ones, they had an @v1, @v2 or whatever. That's a tag number. So you can update version 1, but not after you've released version 2 because it's just picking up the right tag. So that's quite cool. Yeah, Lamina's automatic releases is worth a study if you want to get into writing your own GitHub Actions because it's mostly written in PHP. There's no reason your GitHub action has to be written in JavaScript, even though all the examples are in JavaScript. You don't have to do that.
How can you write tests for your GitHub Actions?
Difficultly. Well, it depends how you look at it. If you're writing a third party or an independent action, then it's just a computer program that does stuff. So you can write tests for that like you do in any other repo. If you want to test your workflow, so it depends what you talk about, whether an action or a workflow.
Okay.
So the YAML workflow,
Is there like a X unit or PH unit or something like that?
not that I'm aware of, but your actual actions code is just doing stuff.
Yeah.
At the end of the day, it's calling an API that closes a release in GitHub Actions, in GitHub or whatever. So that's an API call, so you just mock it out. And then you test in the rest of your code with that mock. If you write in an action that talks to Jira, then you're hitting the Jira API. So write a mock server for Jira and test it that way. Or create a version of Jira that you can just hit manually, do it properly. However you would test any other application that makes API calls very, very loosely. There's bits of it that are a bit more complicated. Like if you assume that, because your action is probably going to work on a checked out set of code half the time. So you're going to have to, your test will have to do a checkout of a code base before it can run its action tests, if you're going to do some integration tests. But you'll probably create a separate repo with your test repo that you check out of into. Does that make sense? So it's no different from writing another program in that sense. So an action is, you're going to write your own third-party action, the bit that goes in the uses clause. It's just like writing any other program, but these programs are incredibly communicative. They do a lot of talking to other things. So that makes them as hard to write as any other program that talks to any other thing. If you want to test your workflow, that's much harder. I don't know how you do that. Half the time, the easiest way to do it is just to have 2 steps or 3 steps. The checkout, the bring up the composer, and then run your script that you run locally as well. So run make check within your container, you'll test in make check locally. That also works fairly well. Other than that, I've not found a way, or I've not even tried, to be fair. They're not too difficult. The clever bit is in the actions themselves. And I trust that the semver incrementer action does what it says it does, because that's their problem to test that. I don't have to worry about that. And it's really, really easy to spot a typo in a variable, because you run it once and you cannot miss the fact you've screwed up. It will tell you in a nice red line. So, not sure that helps or not. This is what happens when you... Oh, there we go, it's gone. Okay, anything else? We good? Is that helpful?
Yeah.
Cheers.